All right. Good afternoon, everyone. Thanks for attending the last of the C406 series today. We're lucky to have Anna have done such a great job in the last three sessions. So thank you in advance for closing us off on a good note. All right. Let's see. Training sponsored by Colorado Energy Office with training materials created by Group 14. Anna and I have been working with the Energy Office for a few years now to provide trainings just like this one. You can see the next webinar series is not until the first Wednesday of December, so definitely check that out if you're interested in hearing more about ComCheck. And then we will be doing a residential series for R408 and the LECC versus IECC 2024, but that'll probably come in the new year, so just keep an eye out for that. All right, if you're a jurisdiction looking at adopting to the latest codes, we're here to help. If you are touching any of the energy codes, and you're also looking at like the IBC, IRC, other amendments, we can help with the entire suite. So I've got some things listed on the screen now for how we can help you, but it's not limited to that. So definitely reach out to me if you have any questions or want to talk further about it. Got a whole bunch of resources available. There's more coming down the line. And then the Building Energy Code Resource Survey is also live right now. So I'm going to post that in the chat and hopefully can keep gathering some solid feedback. We've had a lot of responses and it's so appreciated. It helps us inform to what we should be developing next and prioritizing. All right, last but not least is the Colorado Codes Helpline, probably my favorite resource. And it's great because you can submit a question on any of the building codes and subject matter expert gets back to you within a couple days. I know I've used it for the plethora of house projects that I have going on as well and trying to figure out how to comply with the IRC. So I encourage you all to use it as well. All right. I'm going to go ahead and stop talking because I know that this is a big topic today on renewables and load management. So I'll let you take it from here, Anna.
Okay. Thanks, Erica. Hi, everybody. For those of you who don't know me, if you haven't been at the previous webinars of this session, oh boy, we're off to a good start. My name is Anna McCullough. I'm an energy team leader at Group 14. I have been energy modeling and working with the code for a very long time. If you guys have any questions, please post them in the chat or the Q&A box. I try and keep track of them as I am presenting so that as questions come up, we can answer them because a lot of times, a lot of people have the same question. They just don't put it in the chat. So please put your questions in the chat. Today, we will be talking about the renewable and load management credits of Section C406 of the Model Low Energy and Carbon Code. There we go. So there are a couple of differences between the 2024 IECC as they structured renewable and load management credits and the Model Low Energy and Carbon Code. The 2024 IECC renewable and load management credits. So these credits that we are talking about today are mandatory. So if you are complying prescriptively via ComCheck, you have to comply with achieve a certain number of credits under renewable and load management. If you are complying via the performance pathway, you also have to achieve a certain number of credits from the renewable and load management credits section. So it's really important to understand how they work and recognize them as kind of mandatory for all buildings under the 2024 IECC. Also under the 2024 IECC, excess energy efficiency credits, so those credits we've been talking about in the last three classes or webinars, can count towards renewable and load management credits. However, If you want to go the other way and use your renewable and load management credits to offset some of the required energy efficiency credits for the prescriptive pathway, there is a limit to the number of renewable and load management credits that can be, a number of energy efficiency credits that can be offset with renewable and load management credits. If you are complying under the 2024 IECC with the performance pathway, excess energy efficiency does not count towards the renewable and load management credits. Now, CEO and the Energy Code Board took this structure under Section C406 and updated it to make it a little bit easier to understand. It's just like it's very difficult in the 2024 IECC to figure out the credits and where and who and what and why and how. But under the Model Low Energy and Carbon Code, what the code has done is taken the renewable and load management credits, made them optional, so they are not, it is not mandatory for you to comply with just these credits, and put them in with the energy efficiency credits. Now, they did increase the number of credits that you are required to comply with, but now the renewable and load management credits are a part of that bucket. There are, however, they did add limits to the number of on-site or off-site renewable credits that can be counted towards the total number of required credits. So what that means, and we'll go through the charts here in a second, but that's kind of the general structure overview. So this is the 2024 IECC, and like we talked about, there are charts in the 2024 IECC that show you the number of energy efficiency credits you are required to comply with and the number of renewable and load management credits. If you achieve excess credits under energy efficiency, those count towards your renewable and load management credits. However, if you achieve excess renewable and load management credits, you can only count X number of credits towards your energy efficiency credits. And so that changes based on climate zone and occupancy group. For example, a multifamily commercial building in climate zone 6B can only count 5 excess renewable and load management credits. So sorry. Towards the energy efficiency credits. The Model Low Energy and Carbon Code, like we talked about, has combined the energy efficiency credits with the renewable and load management credits. And in order to keep designs from just like designing a really bare bones building and then just slapping a ton of PV on it or buying a bunch of off-site PV, they have limited the number of credits that can be achieved from renewable energy. So group R2, it's 5 credits for climate zone 6B. So as you are going through and working out how many credits you are going to attribute to each credit section, the maximum number that you can get for credit R01, the renewable energy credit under the Model Low Energy and Carbon Code, is 5 for your multifamily commercial building in climate zone 6B. Any questions on the structure before we get into the credits themselves? Clear as mud, probably. Okay, I've read it about 50 times, so it makes a lot of sense in my brain. If you guys have questions or need me to go back over something, please let me know. Although maybe I'm just telling you things you already know. But anyway, feel free to ask questions. So the first renewable and load management credit is R01 renewable energy. Sorry. So in order to achieve credits with the renewable energy credit, you need to have installed at least 0.1 watts per square foot of building area, or you have to secure off-site renewable energy credits. based on this calculation. So, this is a long calculation. It's interesting, this calculation was updated in the Model Low Energy and Carbon Code. Under the 2024 IECC, any renewables that you are using to comply with Section C405.15, which is the mandatory on-site renewables section, have to be removed from this calculation. So you can't count those renewables that you're using to comply with the base code towards your additional renewable and load management credits. So this is the Model Low Energy and Carbon Code version of the calculation. So we have the credits received equal the base credits from the table, EC 0.1, times RT, which is the actual total rating of on-site renewables in watts. That's important. I tried to do this in KW before I really read through the calculation. And it obviously didn't work. So it has to be in watts. Plus the equivalent rating of offsite renewable energy contracts in watts. And that number is basically derated based on table C406.2.8.1.1, which we'll go through on the next slide. And the amount of solar expected to be produced by those offsite renewables. And then you subtract the rating of renewable energy resource capacity excluded from the credit, which would be the rating of any renewable energy resources used to meet exceptions of the code. So something that comes to mind is solar hot water. If you're using that to comply with the requirements of section, I was going to be very impressed with myself if I could remember the subsection, but section C404, then that would not be able to count towards this credit. And then the rating of any renewable energy resources used to achieve other energy credits in section C406. So the other one that comes to mind off the top of my head is the service hot water, renewable service hot water credit that you could achieve credits for by providing on-site solar hot water. And then you divide all of that by 0.1 times the project gross floor area. Table C406.2.8.1.1 is an estimate of the expected kilowatt hours produced by an offsite, by a large-scale solar system in the different climate zones. So if we look back at this equation, and I have it copied here again at the top, if you are purchasing offsite renewables, you take the total capacity of the in kilowatt hours of that offsite renewables, divide it by this ratio. So for that multifamily building in climate zone 6B that we were talking about, it's going to be 1.55 times 20. And so that's the code's way of derating those offsite renewables. They have a lower first cost, and it's less of a burden to the developer owner, building owner. And so they are rated as less efficient. So there are also requirements around offsite procurement. You can use any of the following. You could use physical renewable energy power purchase agreements, financial renewable energy power purchase agreements, community renewable energy facilities, offsite renewable energy system owned by the building property owner. So if you have a school that I'm working on comes to mind, right? It's a new building that they're building on their campus, and they have a large amount of solar on site that they own the RECs for. And so they could use that to comply with this credit. A renewable energy investment fund or a green retail tariff. The generation source shall be located where the energy can be delivered to the building site by any of the following: direct connection to the offsite renewable energy facility, the local utility or distribution entity, and then an interconnected electrical network where energy delivery capacity between the generator and the building site is available. The offsite contract duration is also required to be not less than 10 years and has to be structured so that it could survive a partial or full transfer of ownership of the building property. So you do have pathways for compliance with the renewable section for offsite. You have to provide more capacity if you are wanting to comply with the renewable and load management credits via offsite renewables. Credit G01, lighting load management. So any project that is not required to comply with section C405.2.8, which we'll go through in the next slide, can achieve energy credits for installing demand responsive lighting controls that comply with C405.2.8.1. So that's how the controls work, and must meet the following requirements. So they must automatically reduce the light output or power of controlled lighting to not more than 80% of the full output. So if you remember those high-end trim controls that we were talking about on Tuesday, we had to set the maximum output of the total fixture to 85%. And now we have this compliance pathway for the load management credit, where in a instance of a peak demand event, the maximum capacity would be 80% of that 85% that we were allowing. So our high-end trim set point is 85% of the lighting fixture's total output, and we reduce that to 80% of the 85%, not just to 80%, which I guess I probably should have calculated out. Another requirement, not less than 10% of the interior floor area in group R or I occupancies have to have these lighting load management. And then not less than 50% of the interior floor area in all other occupancies are required to have this. So the idea here is that if you are a residential type occupancy, you can just have these lighting load management controls on your common spaces, the spaces that serve your residential occupancy. And then all other occupancies have to comply with 50% of their floor area. Where only 75% of the qualified floor area meets the requirements on the previous slide, the credits are required to be prorated. So if 75% of your 50% that's required to comply, if you're only, oh my goodness, if only 75% of the required 50% comply, then you prorate the credits basically by reducing them by 75%. Section C405.2.8, interior general lighting. So this is a section that was updated by the Model Low Energy and Carbon Code and is significantly different than what's in the 2024 IECC. Interior general lighting in groups B, E, M, and S occupancies shall have demand responsive controls in not less than 75% of the interior floor area. So already, there are exceptions. Let's go through the exceptions and then we'll talk about it. The exceptions are where the combined interior floor area of the qualified occupancies is less than 10,000 square feet. So if you have a small office in a large warehouse building or large industrial building, let's go with that, you wouldn't have to comply. Where buildings where a demand response signal is not available from a controlling entity other than the owner. So if your building is located in a place where there is not demand response from a controlling entity that isn't the building owner, so like the utility, then you wouldn't have to comply with this. Parking garages aren't required to comply. Ambulatory care facilities, outpatient clinics, physician or dental offices, or spaces where health, safety, or productivity of occupants would be compromised by light level reductions, like an industrial plant. You can't reduce the light levels when people are doing very technical things where you need a lot of light. So this automatically, this section, you have to, in order to get credits under credit section G01, you have to be one of those occupancies that isn't required to comply with section C405.2.8. So already this is kind of removing this credit section, this credit's applicability from the majority of buildings. G02 HVAC load management requires controls that are configured to provide a cooling temperature shift, a heating temperature shift, and a ventilation shift. And we'll go through what those are required to be on the next slide. The credits are calculated using the following equation. So you have the credits that you achieve equal the base credits from the table times the adjustment factor. And the adjustment factors are found in table C406.2.10. That adjustment factor is right here. So the first column here of our adjustment factor table is a demand response signal available from a controlling entity other than the owner? Yes or no, right? Is your utility have a demand response program that is available? Is demand response required by section C403.4.6.1? And we will go through that section. And do your controls include a ventilation shift? So if we are in a location where a demand control response signal is available, we have, it is not required, and we do include a ventilation shift, we are going to achieve 80% of the credits available. So as we're talking through this, I want to talk about the difference between load shedding and load shifting. So load shifting is the idea that we are cooling something down or heating something up before we are looking to reduce our peak demand. So as we are talking through, we want to make sure we're using the right language to talk about a load shedding and load shifting. It's something that as I was reading through this, it frustrated me because this is a very common way to talk about demand in the kind of controls world, right? Are we shedding the demand or are we shifting it? And they talk about a cooling shift and a heating shift when really this is a shedding situation, not a shifting situation. So I just wanted to clarify this. Load shifting is when we are making ice at night, for example, and then using ice to cool down our building. We're making domestic hot water right before heating up all the domestic hot water in storage tanks to 180 degrees before we have a peak reduction event. Load shedding is we're just traveling along as normal and we hear that we need to reduce our peak and we drop our temperatures, we reduce our light levels, something like that, that just automatically reduces the peak without future planning. So that's kind of the description there. And now that was my spiel, my soapbox for the day. So the requirements of each of these, a cooling temperature shift where electric cooling is in use, the controls are required to do the following: increase the cooling temperature set point by at least 3 degrees over a minimum of 3 hours, or reduce the total cooling capacity by 60% of the installed capacity. Where you have electric heating, controls are required to decrease the heating temperature by at least 3 degrees over a minimum of 3 hours, or reduce the heating capacity to 60% of the installed capacity. And then a ventilation shift, where the HVAC systems, and this one starts to get a little bit difficult, where the HVAC systems serve multiple zones and have less than 70% outdoor air required. So you can't do this for a DOAS. Controls are required to do the following: provide excess outdoor air preceding the peak period, right? So the code developers who wrote this section recognize that you have to provide ventilation for people to breathe. And so this is where you need to do some of that shifting, right? We're going to provide excess outdoor air before the peak reduction event. And then you're going to reduce the outdoor air by at least 30% during the peak period. Okay. And that's it on that one. G03, automated shading load management. Can be used when fenestration on the south, east, and west facades is greater than 20% of the wall area. So if we have a building design that has a greater than 20% window to wall ratio on the south, east, and west facades, you can achieve credits under this credit section. So if you have exterior shading devices, they must reduce the solar gain through sunlit fenestration by not less than 50% when fully closed. Dynamic glazing could also be used to show compliance, and they would qualify under the exterior shading devices category. If you have interior automatic shading devices, they must have a solar reflectance of not less than 0.50 for the surface facing the fenestration. And you can only achieve 40% of the base credits. As you are calculating, what's my south facade window to wall ratio, any directional exposure within 45 degrees of the cardinal direction counts toward that direction. In order to achieve compliance with this credit, you have to provide coverage by 90%, for 90% of fenestration on the east, south, and west facades. If you choose to provide 70% of the coverage required, to only provide 70% coverage on the south and west facade, so we're not providing any coverage on the east facade, you can achieve 50% of the credits available. There are also controls requirements for the shading devices. So they have to be automatically controlled and modulate in multiple steps or continuously. So like dynamic glazing, if you've seen it, operates continuously. It doesn't necessarily have to have steps. In response to either peak periods and either daylight levels or solar intensity. So if we do have dynamic glazing, we have to also be able to modulate it based on the peak period. You can include or have to include a manual override located in the same enclosed space as the fenestration that shall override automatic controls for not longer than 4 hours. So say you have a conference room, it's not a peak period, but someone wants to close all the shades because they're doing a presentation. They can override those automatic controls that would either allow daylight or not allow daylight for no longer than 4 hours. And then it will reset and the person would have to override it again if necessary. But manual override controls must be logged out during peak periods. So that means if you are having a peak demand event that is being controlled by an entity, those manual controls will not work during that peak period. If someone wants to, for example, open the shades during a peak period. Electric energy storage. Electric storage devices shall be charged and discharged by automatic load management controls to store energy during non-peak periods and use stored energy during peak periods. So again, this is a load shift, not a load shed, right? We store up the batteries, we put a bunch of electricity into the batteries, and then use that to reduce our peak rather than business as usual at nighttime. We're going to increase the energy use at night a little bit and offset that peak. The minimum capacity required to achieve credits under the electric energy storage is 1.5 watt hours per square foot of gross building area. And the base credits are based on an installed electric storage of 5 watt hours per square foot. So if you have less than 5 watt hours per square foot, your credits will be derated. If you have more than 5 watt hours per square foot, your credits will be increased. You can only take credit for up to 15 watt hours per square foot of electric energy storage batteries. Cooling energy storage. Automatic load management controls are required to be capable of activating ice or chilled water storage equipment to reduce demand during summer peak periods. So again, this is a shift, not a shed. I don't know why I feel so passionately about that. The storage tank standby loss shall be demonstrated. Oh, and so this is the requirements for the tanks themselves and how they're going to operate. The storage tank standby loss shall be demonstrated to be not more than 2% of storage capacity over a 24-hour period for the cooling design day. So this tank is insulated. It's probably buried. You know, we are not losing any of that cooling to the outdoor air. Maybe it's located inside. But you have to show a calculation either from the manufacturer or from the design team that shows that you are not losing more than 2% of your storage capacity over one day for the cooling design day. The base credits in this section are calculated based on a storage capacity of the design peak hour cooling load times 1.15. So 15% excess capacity based on the design peak hour cooling load. And then credits are prorated. So if you're providing less than 15% excess capacity and you're down at 50% of your total peak cooling load capacity, you can still achieve credits, and you can only achieve credits up to 5 times the design day peak hour cooling load. The way those are calculated, you take the base credits available, multiply that by 1.44 times the storage ratio in ton hours of storage per design day ton, and add 0.71 and divide all that by 2.15. I would love to see the math behind how this equation was created. If anyone has that available, I was just curious. A lot of them I can backtrack and figure out how they came up with the equation. To be honest, to be fair, I didn't try very hard to back calculate these constants and these variables, but if anybody has it available, I would love to see it. Service hot water energy storage is the automatic, is where we are providing additional service hot water storage to reduce our peak service hot water demand. So automatic load management controls shall preheat stored service hot water before the peak period and suspend water heating during the peak period where service hot water is heated by electricity. The storage capacity shall be provided by one of two options: either preheating the water above 140 degrees delivery temperature with at least 1.34 kilowatt hours of energy storage per kW of water heating capacity required. The tempering valves must be provided at each water delivery location, so you're not burning people. You have to provide an additional heated water tank storage capacity. Oh, I'm sorry. And then the second option is to provide an additional heated water tank storage capacity above the peak service hot water demand with an equivalent peak storage capacity to the above bullet, so that 1.34 kilowatt hours of energy storage per kW of water heating, peak water heating capacity. The credits available are the base credits times an adjustment factor. I'm so sorry. My daughter's preschool teacher just called me and texted me. Everything is fine. Check it. And these are the adjustment factors. So this is really similar to the table that we looked at for the HVAC shift, HVAC shedding credit, load shedding credit. So is your building required to be demand response ready per section 404.10? Yes or no? We'll go through that in a second. Is the demand response signal available from a controlling entity like your utility? Does it have a heat pump water heater? And then you get your adjustment factor. So we'll say it is not required to be demand response ready. It does not have a demand response signal available, and it has a heat pump water heater. So you would adjust your credits by 33%. So section C404.10 is the requirement that electric storage water heaters between 40 gallons and 120 gallons and a nameplate rating of less than 12 kW be provided with demand response controls. This section is written into the Model Low Energy and Carbon Code. It is not in the 2024 IECC. It is also required by Colorado law. So even if this doesn't make it into someone's local jurisdiction's energy code, it is still required by law to have these demand response controls. Within the Colorado Model Low Energy and Carbon Code is the requirement around what the controls are required to do. If they are manufactured before July 1st, 2025, or if they're manufactured after July 1st, 2025. Basically, it's just this AHRI standard 1430. There are exceptions to section C404.10. Water heaters that are required to provide a constant hot water delivery temperature of 180 degrees or greater. Water heaters that comply with Section 4, Part HLW or Section X of the ASME Boiler and Pressure Vessel Code are not required to have demand response, and water heaters that use three-phase electric power are not required to comply with the demand response section credits in Section 404.10. Because they are not required to comply with Section 404.10, they can achieve greater credits for complying with the renewables and load management service water heating credit. G07, have there been, I haven't seen any questions come through. I don't think I've missed any, but please let me know if you guys have any questions. Building thermal mass. So the idea here is that a building has thermal mass that is open to the ambient air inside the building to absorb heat and reject heat. So the building must have interior mass, and it can be a part of your structure as long as it is either just covered by gyp, or it can be, you have an interior wall of a gymnasium, something like that, that is mass, right? Because you have kids that are like going to run into it. Throw kickballs at it and stuff. You can't have steel framed wall. Another requirement to achieve credits under this credit section is that 80% of the gross floor area must be unoccupied between midnight and 6 a.m. So what's very confusing to me under this, the renewable and load management credit availability tables of the 2024 IECC is that our occupancy buildings can use this credit for compliance, but they don't meet the base requirements of the credit to be unoccupied between midnight and 6 a.m. So I have a hard time understanding how they would achieve credits, how they would actually use this credit for compliance. The mass must be interior to the building thermal envelope insulation and provide 10 pounds per square foot of project conditioned floor area in passive thermal mass. It can be in building interior walls, the inside of the exterior wall, or the interior floor construction. So the idea here is in this little graphic on the right side of the slide, we have heat that's being stored in the mass at night, and then during the day, and then at night that heat is being released into the occupied space because all of that mass is being held within the thermal mass of the building on inboard of the thermal insulation, the exterior thermal insulation. Mass walls must be directly contacting the air with directly attached gyp panels allowed. Carpet or mass exterior of the thermal envelope insulation is not allowed to be counted. So if you think about like a sandwich panel or something like that, I took a little snippet of a wall. This green line shows the mass within the wall assembly that can be counted, assuming this is the interior of the space. We have this line of insulation here, so anything beyond this purple line, any mass would not count towards the 10 pounds per square foot of conditioned floor area. So it's only mass that is available to interact with the interior temperature of the space. HVAC units for that supply 80% or more of the supply airflow in the entire project shall be equipped with outdoor air economizers and fans that have variable or low speed capable of operating at 66% or lower airflow and be included in the night flush control sequence. So in order to comply with this credit, you have to have central systems, or you could have like individual furnace type systems that have outdoor air economizers, and they have to have either EC motors or VFDs. Then there are required controls for this night flush. So not only do we have the mass that we need to be interacting with the interior space and the interior ambient air, but we also need to be able to flush out the building at night. So we're going to have summer mode and winter mode. Summer mode is activated when outdoor air temperatures exceed 70 degrees and continue until outdoor air temperatures fall below 45 degrees. During summer mode, the occupied cooling set point shall be set at 1 degree higher than normal, and the occupied heating set point shall be 2 degrees lower than normal. The night flush is activated when the following conditions exist. Summer mode is activated. The outdoor air temperature is 5 degrees or more below the indoor average zone temperature. So if we have a cooler, warm summer night, it's 55 degrees outside and it is an average of 70 degrees in the spaces. This would be when the night flush is activated. The indoor average zone temperature is greater than the morning occupied heating set point. So your morning occupied heating set point would be 68 degrees, and we would be able to flush out to get from that 70 to 68. And the local time is between 10 p.m. and 6 a.m. Then you have to activate this night flush where we're using the outdoor air economizers at a lower than maximum speed to flush out the warm, hot air, use that cool outdoor night air to cool the building down. Outdoor air economizers shall be operated at a low fan speed, not exceeding 66% during the unoccupied period, with mechanical cooling and heating locked out. We're not heating and cooling for this night flush. If you are not in summer mode, you are not doing a night flush. So if it is winter, it is cold outside, we are not freezing the building. It's only when we have cool nighttime air available. And that's the idea that, right, in the winter, we want that thermal mass to release warm air into the occupied space. And in the summer, we want to use the cool nighttime air when that is available to cool down the occupied space. It was a lot. The last credit we have to talk about today is this refrigerants credit. So this was created by the Energy Code Board for the Model Low Energy and Carbon Code. And it is a requirement that projects use space heating and service water heating equipment utilizing low GWP or ultra low GWP refrigerants. And there is an adjustment factor. So if you're using the ultra low GWP, you are going to achieve 100% of the credits available, which in the Model Low Energy Carbon Code, there are about 1 or 2 credits available based on climate zone and occupancy type for this credit. It's not, you're not getting 50 credits for this. If you select a low GWP refrigerant, then you achieve 50% of the credit, and if you have a greater than 150 kilograms of CO2 GWP limit, then you will not achieve any credits. I did pull down this chart that shows the type of refrigerants and their GWP as just like an easy reference. You'll see that if it is not in a box, it is not a low GWP or ultra low GWP refrigerant. The only low GWP refrigerant on this in this table is the R454C. That's at a 148. It is an A2L. You guys, I'm sure, have heard of all the talk about the A2L refrigerants that are required. And then the ultra low GWPs are going to be these propane, R120, 1234 ZE and YF, ammonia, water, and CO2. And I do want to highlight that this is the requirement for space heating and service water heating equipment. So if you just have, your rooftop units are using R120, oh my goodness, R1234 YF, you are not, but your water heaters are using let me think of a good one, 410A or R454A, you can't comply. It has to be all of the refrigerants in the building. That was it. So if there are any questions, please let me know.
Still muted. There we go. We'll get there. All right, any questions? Feel free to raise your hand or write in the chat or the Q&A.
Maybe put everybody to sleep today.
You've been trained out. Lots of training this week. Looks like we got something in the Q&A.
Oh.
Oh. Okay, how do we trust and verify RECs?
Hmm. So that's a good question. The recs have to meet all of these requirements. So you have to be buying recs that are within the electrical network, within the local utility or distributed distribution entity. Um, I think they need to be from a verifiable source. You need to see the contract signed. That's just kind of the best you can do, unfortunately. I feel very wishy-washy about Rex as well. It seems very like nebulous to me sometimes. And like, how do you know what you're actually buying and where is it coming from? And is it like an actual efficient solar field, or was the field built in like 1995 and things are ending, and it does feel a little bit
Yeah.
less than stellar. But I also think, with the Colorado Model Low Energy and Carbon Code limiting the number of credits that are available from this credit R01, it discourages, or it really doesn't allow buildings to just purchase a ton of RECs and be in compliance with Section C406. It really is a small number of the total credits required.
I know some jurisdictions do amend the RECs option out too. So,
Mm.
just something to kind of be aware of too. Every jurisdiction is gonna might alter it to what works for them. So something to keep in mind as well. And Nick, if you need examples of that, just let us know. Okay, we got another
Okay.
one. Can you please expand on the electric heating and cooling eligible for credit? Cooling tower is electric cooling because of the chiller, question mark?
Yeah, so basically all cooling would be able to use this HVAC load management credit because we use electricity for cooling. Um, if you had evaporative cooling, you're right, you would not have to. But if you had evaporative cooling with backup DX, then you would still be able to comply using this credit. Um, But if you're talking about a chiller or a VRF system or a heat rooftop unit with a heat pump, you would be able to use this credit because you're using that electricity to remove heat from the air. If you're using just direct evap water to remove heat from the air, then you wouldn't be able to use this credit. That's a good question.
Great. And Nick, I saw your comment in the chat that you're considering amending it out. If you need any support on that language or want to work with a subject matter expert on that, happy to help. So we can kind of tailor that. Okay, another question. If the project was an aquarium, could I use the tanks as a thermal mass credit?
That's a really good question. I don't think so because you have to be, oh, I guess it depends what temperature the water is and how much water you have. So the tanks would have to be open, be able to supply cooling to the space. So if you think about like a really large, I guess the last aquarium I went to, it's been a while, but the really large tanks are kind of like open to the outdoors or not open to the occupied space where we're providing cooling. Um, and then you would also have to think about, so how do I reject heat to those tanks without changing the temperature of the aquariums in a way that could potentially damage or hurt the animals? I don't know. I guess I don't know enough about aquariums, to be honest. I'm kind of making this
Yeah.
up as I go, but I could only imagine that they have like very strict temperature set points for the
Yeah.
dairy animals. So I think it might be really difficult, but I would love, it'd be cool to see it work. I don't know.
Yeah. I feel like if there's a will, there's a way, but how
And
about an
in
indoor pool?
an indoor pool, because you are heating the pool, if it was like a plunge pool and you were keeping it really cool, then you could potentially use it. But because typically we are providing heat in those natatoriums, indoor natatoriums, to keep them warm, it wouldn't necessarily work as a heat sink or a chilled water creation. Oh my gosh, cooling energy storage opportunity. The something that kind of grinds my gears about this is that you can use thermal energy storage for service hot water heating, but there is not a credit for heating hot water energy storage. So storing large tanks of heating water to reduce peak demand, which is,
Mm.
it really frustrates me because that's one of the more effective ways to reduce your peak demand in the winter when you have a electric boiler or a heat pump chiller that's creating your heating water with a backup electric boiler.
Yeah, maybe it's something to consider for the next update.
The 2027 IECC draft one is available for comment right now. Look it up.
There you
Start
go.
commenting on things. Get in there.
All right.
Okay, we got
The next
another.
question. For demand management credits, what if the utility does not yet have the capability to send a signal?
So that's where you're looking at these adjustment factor tables. So if there is no demand response signal available, then you're down here and you're adjusting your credits, oopsie, by 50% or 17%, for example, in the service hot water storage. The idea is that you would have the infrastructure available for when the utility can provide that demand reduction signal? It's a good question.
Okay. Let me go ahead and stop the recording.